Good afternoon. Can you hear me over the drilling? Yeah, real-time feedback. That's one. So thank you for coming to this talk on tools, tips, and techniques for real-time developing real-time apps, with a focus really on the development process, but also the choices you make in terms of the software and technology you use in your apps. My name's Phil Legater. I work at Pusher. Prior to working at Pusher, I worked at a company called Kaplan Systems. There's two gentlemen down here who represent them, so please hassle them afterwards. I've learned a lot from around building real-time apps, the techniques and so on from working there. It's not the nicest looking app, this one. There are nicer skins, but quite complex UI, powered by SDKs, integration with real-time data sources, and also obviously lots of real-time data. I now work at a company called Pusher. We're a hosted real-time service that helps you integrate real-time data and functionality into web, mobile, and IoT apps using any technology you're most comfortable in, basically real-time infrastructure. So, who's heard of Pusher, by the way, out of interest? Okay, pretty good. You've all heard of Pusher now, so you should have all raised your hands. It's a test. So I want to cover why real-time. I'm going to laugh every time I say real-time now, which is going to be difficult. And I also want to cover those tool tips and techniques. So I'm going to work my way through your real-time stack, from sources of data through app servers and real-time servers, which might be the same thing, and then your client application, with a bit of a breakdown in terms of thinking about networks and the libraries that you're doing, probably associated with your real-time server. I'm going to touch on application logic a little bit. I'm not going to talk about UI. If you're interested in UI performance, then you should probably be in the Angular track. Okay, that's good. No one's leaving. Great. So why real-time? Who knows what a notification looks like in an app and what you're meant to do with it? Come on, everybody. So we've all seen notifications. It's an indication that something related to some data that you are interested in has happened. And any person now will see something like this bar and go, okay, well, I click on that and I get the additional data that's been delivered to the browser. Activity streams are, like the lifeblood of social networks, and actually have really driven real-time technology forward in terms of demonstrating a great use case. So the idea is that you can see a history of data, history of things that have gone on, and any time that new data is available, it's pushed into the view at the top of the stream. And again, most people who use Twitter, Facebook, Google+, even news sites now and sports sites have this idea of a real-time feed of data that's going on. As human beings, we like to consume data in visual form. I guess most of us prefer a visual form, so it makes sense that if you add a real-time element to those visualizations, it helps you identify trends, see things that are happening, and ultimately act upon changes or things that are happening. So visualizing these real-time changes in data. Who uses some sort of chat application? Okay, everybody, right? So we all know the value of instantly communicating with colleagues, with friends, with family. Mary Meeker, who works for Kleiner Perkins, did an internet trends report study. She does every year, and she identified that 6 of the top 10 most used applications are indeed messaging applications. So they're massively popular. They're ultimately chat, and they're powered by real-time technologies. I wanted to highlight Uber as a great use case. They've obviously revolutionized the taxi industry to a certain extent. Whether that's positive or negative depends on whether you're a taxi driver or whether you're a user of the service. But part of that experience is the application that provides you with real-time feedback of where that taxi is coming towards you. You can be sitting in the taxi and making sure you're going in the right direction. So it's a user experience that we're all seeing the benefit from. Who's used something like Google Docs? Okay, so the idea there is that you're saving a lot of time. Instead of editing a Word document, checking it into SharePoint, heaven forbid, checking it out again, editing it, checking it back in again. Instead, we write a draft, we share it with everybody, and we collaborate on it in real time. This is actually Atom Pair, which is a plugin for GitHub's Atom Editor that Jamie Patel at Pusher wrote to let you collaborate in real time on code with other developers. Anytime we create a technology, we build games with it. It makes sense that we build games out using real-time technology as multiplayer games. This is Sebly on Twitter. I don't know how to say his surname, sorry, but I was recently at Symphony Live, and he talked about creating a real-time multiplayer lunar lander game, and then he kept the trails in to create real-time art, which is pretty cool. IoT. There's obviously lots of stuff on IoT. Sometimes it's great, sometimes it's not so great. This is actually pretty impressive, really, the robot, but I don't know about the falling over. But obviously, it's about real-time communication between devices, and the technology is a fundamental part of that. So, with the exception of the falling over robot, most of these examples provide some sort of real-time user experience that benefits the user. So whether it's something like Facebook becoming more social because of real-time, or it's a better customer service experience with real-time functionality in something like user voice, or the collaborative element of Google Docs, or the real-time feedback nature and experience of Uber. That it's getting to the point that my mum isn't obviously saying, where's the real-time UX? But if she's seen a better experience in another application and it's not present in the current application she's using, she thinks the application's broken. So without a real-time user experience, it can feel like your application is missing something, that maybe it's broken. So that's why real-time. I want to get into these tools, tips, and tricks. And you've already seen this. I've broken down an application into these kind of 4 components or system elements. Whereas the data sources might be kind of APIs, databases, web point interactions that will ultimately hit your app server through to your actual application server doing some of the work, and then the apps that you're building. Now, from the examples that you've seen, in my development experience, I focus on browser, but I think a lot of these techniques will be applicable no matter what the client type is that you're building. Who here thinks they have real-time data in their apps? So who thinks they don't have real-time data? Okay, everybody has real-time data in your apps, I hope. I could be wrong, I don't think so. Any kind of incoming data into your app, the point at which that data is arriving, the data payload, the event, there's real-time data associated with that. If data changes within an application, that change event is also a real-time event with associated data, the data that was there, the data that is there now, and the change. Any interaction between a system, whether it's a database interaction, whether it's a web endpoint interaction, whether it's an interaction with a queue, all of those things are events with associated data. Obviously, user interactions. If you're building an app with a user, you have the interaction that they're making, and you have the data they've entered or how they're manipulating the app to do what they want with it. All of those are real-time events with real-time data. Is anybody not convinced? Have you got real-time data in your app? Oh, I haven't got an app. Well, that's going to be tricky. Yeah, okay. That's a fair point. So where do we find this real-time data? Obviously, your data sources, as I mentioned, like databases, queues, third-party services. Your app server, the interesting thing about the app server is that if things interact with it, they're not actually creating the data themselves. So there's maybe real-time data in the app itself, but they're normally from like the external things. It's open for debate, hence the question mark. The servers themselves, now obviously they have lots of data being fed into them, but also they might offer specific types of functionality like connections, user presence, or maybe chat-specific features with events and real-time data. And obviously your client application, whether it's a signal from a device turning on and off, or humidity, or whether it's a user interacting with the app. So there's real-time data. So I'm going to make my way through from data sources through to client applications. But the first tip is this the second tip? Tip number 3. I'm going through these fast. In every decision that you make throughout your system, you need to think about where you're ultimately delivering that data to. So the client application, what is it you're building, and how will that affect that client? What like user experience will it deliver? What performance considerations have those clients got? So when the data reaches them, what do they need to do? So always think about the decisions you're making anywhere in your application architecture, how it's going to affect that client. So looking at data sources, as I mentioned, APIs, services, queues, and so on. And there are lots of APIs now that offer real-time endpoints of some sort. You might interact with them through a library, in which case you'll probably have code callbacks, or it's kind of abstracted away from you. If you're accessing and interacting with these services in kind of a more raw form, you're going to have maybe a webhook callback, so an HTTP request, normally in post form, being made from the source of the service to your application server, with a payload, obviously. HTTP streaming, so you make a request, you hold that connection open, and you consume data over that open connection. Or WebSocket. So WebSocket has been built with kind of client-server browser in mind, but there are plenty of real-time API endpoints that are offering WebSocket that can be consumed by any technology that can basically make a WebSocket connection. So one of the problems with this is that when you're starting to build an app and consume data from these third-party sources or from any source, you end up with things like this, where you like, I'm connecting to the Twitter streaming service right now, and I'm waiting and I'm waiting and I'm waiting. Ultimately, I want to get some tweets in so I can start building some stuff. But I give up and I start again. Conversely, you can have something like this, where again, I've changed the keywords I'm searching for. I've suggested I'm going to go for a few more popular keywords. And I end up with this, which is similarly difficult to develop against because you've got all this data streaming in and you're kind of going, well, so ultimately it's quite difficult because you can't control when you get the data or exactly the format of the data. You know, if you've built anything against the Twitter API before, you've probably gone to your Twitter application and sent a tweet to make sure you get it. But that's not a particularly efficient way of building these sort of apps. So the solution is generally capture and replay, or build some fake sources of data for you to build upon. So it would seem that a nice solution to this would be to stick a proxy in between the data source and your app, capture that data and use that proxy to replay, maybe chuck in some stuff into some logs. Webhook tools, there are a whole bunch of webhook tools. Who's used the webhook API before, consumed a webhook? Okay, a few people. Who's tried out ngrok? Okay, so more of you than have consumed webhook tools. So it can be used, obviously, for dealing with HTTP requests as well. So I would definitely say a tip is to use ngrok. It's great. Here's a little video. It's a tool that you install. Where's my cursor? Can I start that? So here I'm kicking off my web application. I'm going to go to it locally just to prove it's there, localhost 5000. And I'm going to start ngrok, and I'm going to say subdomain pusher, and then I say 5000. I do this too quick. And what that does is opens a tunnel between my machine and the internet so that you can access via a public URL. So it's pusher.ngrok.com. So I can go to pusher.ngrok.com and I see my local server. Also, ngrok provides this really cool dashboard that you're running the ngrok tool locally, so you can go to the dashboard and you can see what's coming in through this proxy, ultimately. So in here, I've got a webhook callback from Pusher. In this case, it's like if somebody subscribes to a channel, make a webhook call to this endpoint, and I'm saying pusher.ngrok.com/webhook. And then I go to this page here just to fire the webhook. You can see these false things being logged. That's the webhooks coming in. If I refresh ngrok for some reason, I see these post requests coming in as well. I'm going to fix my code, so I'm actually returning a 200 response and restart the server. And we'll see actually the webhooks have been queued by Pusher because they were failing, so it's coming in again. And I can also click on the replay button and replay it locally. So we're doing this capture and replay stuff, which is really useful for dealing with these incoming webhooks. For WebSocket and HTTP streaming, you could look at a proxy, but I've got to be honest, I couldn't find anything that was really doing that capture and replay functionality that I was looking for. Does anybody know of one? Something that will sit as a WebSocket proxy and being able to manipulate the data. So I also found Gore, which looked pretty good. It does offer HTTP capturing and replaying, but it doesn't offer WebSocket support, and I don't know about streaming. So the solution is log all the things ultimately. So if you're capturing this data as you're starting your development process, chuck things into a log, and from there you can simply monitor. You know what's going on. You can filter them. You can build little tools around them, little things that just replay functionality. I've done a bunch of work with Opta and also stats.com around real-time sports, and that's exactly what you have to do. They will, in fact, provide you with a set of XML documents, and you have to build tools around that to start building apps on top of it. I looked at some logging tools. So what logging tools exist that might offer this reading and replaying functionality? And a bit like this video, everything seems very shiny and enterprisey, but there doesn't seem to be this nice little logging tool that I can parse a log and replay data through it. I even asked at work, and it was like, logs are standing out, which is nice because you can see what's happening within your apps. Use a standard log format. So log format is actually a standard that Heroku use. And then grep said no. I don't know. I don't think that's particularly, it's valid, but I think we need better tooling around this. This is maybe something that we might look at doing so we can capture the data that's coming in and capture the data that's coming out and help replay that sort of stuff. So how does the client fit into all of this? So we're consuming all this data from our server is consuming all this data. So the tip that I would say from this is that you're getting all this data, and there's a tendency at the moment to chuck stuff to the client and make the client do a lot of work. The browsers are pretty amazing now, our mobile devices are pretty amazing, but they're still not as powerful as our servers. So take the opportunity when you're consuming that data on your server to do the work on it. Now, I was speaking to Ewan from Kaplan yesterday about this, and he went, well, that's not necessarily right, Phil, is it? Because if you think about it, sometimes if the data is highly time sensitive, then doing any processing will delay the delivery of that data to the client. So there are always caveats to this sort of thing. But generally, do the data processing and decision making on the server. So the application servers themselves, things like querying, obviously you might want to be chucking it into a database and updating a query, doing some transformations, taking it from the lovely XML format through to the JSON format that you probably want, and also things like data formatting. So it could be that if you're going to be, time is a good example. You get a big time string, and then you send that through to the client. The client has to chuck it into a date object in JavaScript and then parse it out into a nice format. That's additional work that you're asking the client to do. Now, that's probably an extreme example, and if you're fine-tuning to that extent, it's maybe a bit over the top. But there might be situations where you could do a little bit more formatting on the server, even send HTML that could be directly rendered in some situations, heaven forbid. But there are obviously, again, caveats to that, because if you do that, then you can't then stick a mobile device and consume the same feed of data. So this is a tweet. So there's a lot of data in a tweet now, right? So if ultimately I'm just building an app that's to show who sent the tweet, the time, and the tweet content, then I don't really want to be sending all that. I just want to be sending that data. So that's a really simple example of improving the efficiency of an application by only sending what's required. Another nice example is that if you maintain the state of data, so say it's a football score, you've got Liverpool versus Arsenal and it's 0-0, and then an event takes place and Liverpool score. I used to support Liverpool when I was a kid. It'll be John Barnes, if anyone's that old. John Barnes scores. So the data that's changed is really just home team score and the event time. So you only really want to be sending that data through and not all of the data. So, and you get more benefit from that the larger the initial payload. So upon initial connection, send all the data. From that point on, just send those changes. So this was me building a UI and consuming the real-time feed that you saw streaming past earlier. And this is kind of a non-existent UX. You try and build a real-time Twitter viewer, and you can't even really see the images, don't get a chance to load. There's no way I can read it. So this is basically pointless. So if I'm consuming all this data and I'm sending data too quickly for the use case I'm trying to build, then it's just a waste of time. So you've got to control that update frequency based on the experience you're trying to deliver. I've obviously Googled this and just found it online. So 100 milliseconds for a human being to feel that something is instantaneous. Now with games, I guess it's 600 frames per second. I don't know how that translates. But you need to kind of think about this experience that you're delivering. 250 milliseconds if there's any kind of reaction to be made. So obviously with Twitter, you're not trying to click on them quickly, but if you're trying to build something that requires some sort of reaction, the human being has to have at least 250 milliseconds to respond to that. And each of these updates requires some parsing. So you could see as a pretty janky front end that it was really slowing down. The experience was terrible. So data was having to be parsed, HTML templates rendered, and the UI update. It was pretty rubbish. So you can also consider batching. So if you're getting all these updates and you can stick them all in one message payload rather than sending them individually, that can also be an efficiency improvement. So we're moving on from the server through to the real-time framework. In the same way that we want to know what's coming from the data sources and keep track of that, being able to build tools around it, we need to make sure we know how we're processing the data. We also need to kind of know what's going on within our real-time framework to be able to make sure that data's going in as we expect and data's going out as we expect. And also the internal functionality is working. Are those events about connections occurring so that we can make sure we can build functionality around connectivity? So these frameworks need to be able to expose things like connections, subscriptions, people requesting data, people unsubscribing from data, the actual messages that are going in and out that you're sending, this idea of presence, users coming online, going offline, and any features that they provide, that all needs to be logged. Now, I appreciate logging's pretty dull, but it is a fundamental requirement, to the development process if you really want to be able to develop these things efficiently. So again, log all the things, build tools around that. Now we have, at Pusher, we're obviously a hosted service, so we have built a tool that lets you see the data, especially with this hosted service when you're kind of throwing data at an HTTP endpoint and you're hoping it's getting there, like what's happening. So we exposed this tool that lets you see what is actually happening in Pusher. So this is an app, and this is actually consuming the Twitter streaming example that I had previously. So I've actually refreshed the page somewhere and I've got a disconnection. This tweet channel has been vacated, so there's no subscription to it now. The connection, as the page is loaded again, has come in. I've then subscribed to the Twitter channel, and then it's occupied, which means there's at least one subscriber. So then I go and I'll start my Twitter streaming source, which isn't a great idea. It's called Naughty or Nice because it was like a tracking naughty and nice keywords for Christmas a while ago. And then I'm going to basically break my debugger because I'm throwing in all this data. But the idea here is that I can eventually inspect some messages. I'm clicking, and then I pause. And I'm clicking again. And eventually I can open up a message down here. They've obviously streamed by. And somehow I've also clicked on one of these circles, which is like replay. I don't know how I've done that. Like the UI was basically broken because there was so much data going in there. And then I can resume it. So I think these tools are really valuable, not for like what's going on in the application right now in live production, but certainly during the development process. So build tools that I can capture and replay this functionality will really help the development workflow. There was something called Socket.io UI that someone had built this sort of thing, but it hasn't been updated for a year. So I'd really like to see more tools around that, whether it's Socket.io, Fay, SignalR, whatever the real-time framework is. I think as part of the development process, these things are really valuable. It's not that visible. So we need tools. So what about the connectivity? Now I'm going to fly through this. So I'm not expecting anyone to kind of take a lot from these. I'm just trying to make a point. So we've got a connection from our real-time server to our client, and we need to make sure that we're choosing the most appropriate transport type for that client, whether it's something running on a Raspberry Pi, or whether it's a laptop, or whether it's a plug, or whether it's anything that could be connected to the internet, connected to a real-time framework. So you need to make sure you're choosing that base layer of connectivity appropriate for the network, appropriate for the client. You then need to choose a protocol. So which of the protocols meet your needs? Some of them offer pub/sub functionality. Some of them are like massive XML chunks, XMPP. There are loads of protocols to choose from. You then need to pick what I'm calling a communication pattern. I don't know whether that's necessarily the right way, but there's an idea of just sending a simple blob of data, simple messaging. There's pub/sub, so you subscribe to a channel, and you get the data on that channel. There's evented pub/sub, where you subscribe to a channel and you bind to events on that channel. So it can be I subscribe to activity, and then I bind to the new activity, activity updated, activity deleted. There's RMI, so if you want to make requests over the wire and let the framework handle the fact that you call a function in JavaScript on the client, and it will basically work out which function you're trying to call on the server and vice versa. And there's data sync. So if you think about Google Docs as a collaborative document with an underlying data structure, there are frameworks that deal with you manipulate that data structure in code, and the framework deals with synchronizing those changes. You need to work out which one of those kind of fits to what you're trying to build. And I've got this diagram-based communication complexity. So how complex is your business logic, the communications over the wire, or data complexity? Which use case fits best with those different communication types? So there's lots to go into. So ultimately, this is I appreciate this is a bit of a cheeky thing, but just look at the functionality you're trying to build in your application and pick the framework that offers that. Now, that's an obvious statement. And think about the client that you're trying to build and make sure that framework offers the right type of connectivity, the right type of functionality. It's got a native mobile API, SDK and so on. And watch my videos. So 2013, I spoke specifically about choosing a real-time framework because there's obviously a lot of stuff to consider there. But it's definitely something you need to think about. Like, don't plump for Socket.io just because you've seen a Stack Overflow answer that says, I'm a PHP developer, I want to build some real-time stuff, use Socket.io. Because that's not the answer. The answer is to make an informed decision of the real-time framework you're going to use. This is definitely true. Soon you won't be able to go to the bathroom without SSL. The point here is that to use a whole bunch of new features, you need to use SSL. To be secure, you need to use SSL. To connect over mobile networks, especially with persistent connections, you need to use SSL. So there's a whole bunch of features that come to browsers that you won't be able to use, or some existing ones like Service Worker, HTTP2, you have to use SSL. So use SSL in development as well as in production. And then also your development environment mirrors your production environment. So moving through to client applications. I've broken the client application down into kind of like a network layer, generally handled by the runtime, so the device itself or the browser, and then the library and service. The library and service will be associated with that real-time server. So that's the kind of layer that I'm talking about just now. And the great thing is because we've thought about all these things previously, we've done things like making sure that the server's doing the majority of the processing, the payloads are small and focused, formatting, if required, is handled for you. We're controlling that update frequency. Then we've done a lot of the work, and we can kind of almost focus on building our real-time front end. But you still need to monitor the performance of that client, and then provide feedback to the user to let them know if things are working or things aren't working. So things like latency, when you publish messages, put a timestamp on them. Upon receipt of those messages, have a look at the timestamp on your local machine. Consider things like time zone differences and system clocks on the server versus the one on the client. But you can work out this latency. And if it gets really high, you can provide feedback to the user to say, right, well, the data you've got right now isn't as up to date as you probably think it is. The data is stale. Something really interesting that Kaplan specifically solved a while ago was that you've got a lot of data streaming in over the network, and then as the data flows through your application logic, as soon as you introduce things like set timeouts and request animation frames, it potentially gives the network again a chance to kick in, and you start getting more data over the wire, and you can end up with a message queue of unprocessed messages. So you're showing a certain value or a piece of information, but there's messages further down the line in some sort of message queue that say, actually, this data's wrong. So at Kaplan, we had a point at which the UI was showing a certain trade value, and they'd click on it, but the actual underlying view model would have a different value in it because there was this lag, this catch-up. So speak to Ewan, who actually solved the problem with a library called FFS. Is that what you called it?
It's not out.
Okay, but he can tell you how he did it. It is genuinely interesting. I've got a little JS bin that kind of shows this if anybody wants to see it afterwards. So the thing is, if you can monitor that queue, work out how the client's performing, you can start to make intelligent decisions about it. You can inform the user. You can even inform the server to say, hey, I've got all this data, and I can't even process it right now. Can you stop sending me updates every 500 milliseconds? Send it every second. Send it every 5 seconds. Or if it's getting really bad, you can simply reset and just say, stop just now, let me catch up, and then start sending me data again. So this is the bit where you've got your library now interacting with your application. So we've covered a lot of stuff to get to this point. We've talked about like data sources controlling your data, the data considerations, processing payloads and so on, the connectivity, online, offline, because obviously you need to feed that back to some sort of UI to tell the user, hey, you're offline right now, hey, you're online, or the performance monitoring stuff to say the data's stale, it's out of date. And the tricky thing is, ultimately, you're probably just trying to build that real-time feature, that notification, that activity stream, that chat, that collaborative experience. But you've had to set up all this stuff before you can even start building, ultimately, the thing that the user gets to use and that will add some sort of business value. So can I ask, who was in Ben's talk yesterday? Okay, a bunch of people. A bit more interested in this, huh? This is dry. Tips. So as well as waving his hands around and wearing the same T-shirt as me, he had some really cool visualizations. But obviously to build that, he doesn't invite 100 people around his house and say, hey, could you go to this URL and let me test out these slides? Oh, I've got a bug. Could you just hang on a minute? What he has to do, he has to find a way of simulating this kind of experience and building this application which is ultimately an application in slides, out. So how does he go about doing that? Now, I don't know specifically how he goes about doing that, but we've had a few chats. A great way to do it is to have a service or library abstraction layer that you can control and basically mock out, and you write your own JavaScript layer that pretends to be that real-time data feed. And in that sense, you can control the data that's coming out of it. You can trigger fake connectivity events. So who uses Angular? I guess nobody, because otherwise you'd be next door, right? Okay, a few people. So Ember and Angular both got a services layer. In this example I've got on my module, I'm saying, well, if somebody wants the pusher service, they get returned a pusher instance. The nice thing about that is that in the development process, I can just comment out that thing that returns the real pusher instance and instead return a fake instance. And the implementation I control. It might offer additional things that I can call to create fake data. So for this, I created a little example just to prove it wasn't nonsense. So I can, I'm going to have to unmirror my screen. No, I'm going to have to mirror my screen. Okay. So if I kick off my amazing tweet streamer, so I'm getting my non-existent UX, all these things flying in. Again, it would be really difficult. Imagine I set a debugger, like some sort of breakpoint, and then I go play, and all of a sudden it's hit again because the data's streaming in far too fast for me to really do any development. So if I kill that, and instead I go to, this is my, it's a workbench, which is the name that we had for a thing called Blade Runner JS. You would build a component in isolation and have these services that you could mock out. So I've just taken that idea. I've got my pusher JavaScript library. I've got a Twitter viewer component, and this is a web component. I love web components, so they are the future of the web. So if you're interested in that, come speak to me. So this is just the Twitter viewer. And up here, I've got a test stub, which basically overrides the pusher JavaScript API and adds some additional functions. And I've also imported another component, which is a viewer helper, I've called it. So if I save that, and I go back here, and I reload this frame, what this does, it gives me this little component off to the left. But as far as the main component itself is concerned, it still thinks it's interacting with the pusher API. So it lets me send through, fake data like that, and I can obviously control the stuff that comes in. Stuff like that, which is obviously very realistic. But the nice thing as well is because I know the API, I know the events that are triggered from the pusher library, from my service, I can also do things like have a little checkbox which triggers a connection event, which lets me build the functionality that ultimately I want to build. And I'm not having to turn off my Wi-Fi to simulate that connectivity problem. So this services layer is genuinely really valuable, especially when it comes to, well, in general in development, but certainly for real-time data. And the great thing about this as well, if you got the services layer, you could have chosen to use Socket.io as your real-time service to start off with, and then you need to scale to millions of concurrent connections or even hundreds of thousands, and you can drop in pusher without making too many changes. Or if you decided that the functionality you needed was really Signal RMI style functionality, you can swap out that underlying implementation without breaking the public API that your service exposes. So we're now into that AppLogic UI layer, and as I said, I'm not going to go into that because there are loads of great resources on it, specifically for browsers. Obviously, Paul Irish, Eritwist, Paul Lewis, right? Yeah, I think so. Yeah. Is it? And then all browsers now, they've all got amazing developer tools, even Microsoft Edge. Go and speak to Martin, I'm sure he'll demo them to you. And also Ilya Grigorik for the networking layer. Like the stuff that Google are doing around this is genuinely amazing. So definitely worth following those guys and seeing some of these resources. For other types of clients, to be honest with you, I don't do a lot of native mobile dev. I don't do a lot of IoT dev, but I'm sure there will be tools that will help you, make sure that you're building the most performant client possible. So that's 14 tips that are kind of broken down into like techniques or tools or so on. And the whole point in this is that the value you're trying to add is that real-time user experience. And to get there can be a pain. So hopefully those ideas will be really useful in helping the development workflow and also making sure that the components you've chosen within your application you're making those decisions ahead of time, you're following decent practice. That means you really can focus on that app logic and the UI layer, which is ultimately the thing that you're delivering to your users, and that's what you're trying to build. You're trying to build that real-time user experience. So that is it. I think I've got quite a bit of time left for questions, I think.